Hi, today we're going to be talking about graphing. A lot of this is probably review for you. You might hear a couple of things that you didn't know before, but we're going to just make this a really quick introduction slash reintroduction, okay? We're going to talk about data tables, line graphs, bar graphs, and circle or pie charts today. So just a little introduction. Whenever data is collected, a lot of times it is represented in a meaningful way so that others can view it quickly and make sense of it. So if others are going through and reading your lab report or your medical journal or even some kind of journalistic report, it's important that they're able to quickly look at that data table or the graph and determine what information is being represented. Often the data table will be presented in a data table or a graph. Data tables are a way of organizing the information for the reader, and graphs are the pictorial diagram that represents the numerical data that's been collected. All right, so let's look at making a data table. As scientists collect data, it has to be recorded in an organized fashion. It can't just be random numbers written down on a piece of paper. Anytime data is collected in an experiment, it is most often presented in a table. Okay, so if you look here, have a little bit of FYI for you. The data table must have titles, rows, columns, and headings. The title has to be placed at the very top, and it should be descriptive so that the reader knows exactly what they're looking at. Okay. At the top of each column is going to have a heading, and those headings are going to tell you what information is in the column. I'm going to give you a very important clue. The independent variable will always be in the first far left column. The other columns are going to be for information that you collected through the dependent variable, okay? So here we have our heading, star, and 1, 2, 3, 4, all the way to 10. So we were looking at 10 different stars when we were recording our data. And then this was all of the information collected from looking at those stars. Okay, so I want you to, in a second, pause this, and you have a chart that looks like this in your notes. So in a few minutes, you're going to pause this and you're going to create your own data table, and then we'll look at it in class when we see you next time. Okay, so you have a large portion of data, 5 days worth of growth from plants. So what I want you to do is make sure in the very top row you're going to place an accurately descriptive title. In the next row, so right here, right here you are going to place the 2 column headings, and in the remaining rows you're going to fill in the data for the data table. Okay, so go ahead and pause and do that, and when you're done, hit the resume or the play button. So now that we've made a data table, we're going to take that information and we're going to typically put it into some sort of picture representation. Okay, so the first one that we talk about, and the one that we'll typically see, especially in a biology class, is a line graph. Line graphs show data pointed as plots that are connected by a line. So we're looking at something typically that's growth, change over time, and is used to compare 2 or more sets of data. You can represent multiple sets of data on one line graph if you have different lines. You just have to make sure that you indicate which ones those are. Before the line graph can be constructed, the first thing you have to do is identify the 2 variables that are going to go on the x and y coordinates, okay? So you need to make sure before you make your graph that you understand which one is your independent variable and which one is your dependent variable. The independent variable is the one that's being manipulated or changed, and this is the one that's going to go on the x-axis or the horizontal axis down here. Okay? The dependent variable is the observed result of the independent variable, so it's going to be placed on the y-axis. And if you forget which one goes where, I was taught that you can make a D on the y-axis for dependent variable. So this is where your dependent variable would go, okay? If you look closely at this graph, it's hard to see what it says, but there is a title up here. There is a label that says exactly what is on this one and exactly what is on this axis so that we know immediately what we're looking at. Because there are two different lines, we have a key or a legend over here telling us which one represents which. And then you also have to make sure that the graph is scaled correctly. We want to make sure that we use the entire graph area. Okay, we don't just want it to be bunched up over here. So if this one goes all the way up to 10, but there are more than 10 lines. So the author of this graph chose to there are 10 lines, but they chose to make sure that every other line was marked. Okay, and then going across the bottom, each line represents a chunk of information. Okay, so like you made that data table before, using that information, I actually want you in a second to set up this line graph from the data table that you just created. Remember, the first thing you have to do is determine which variable to place on the x-axis and which variable to place on the y-axis. So the x-axis is on the bottom. So go ahead and make sure that you label each axis appropriately. Make sure that you scale them appropriately and that you put numbers on the bottom. I also want to make sure that somewhere on there you've put the units that the measurements were done in. So for the days, make sure that that's clearly indicated that those numbers represent days. And then for the growth, make sure it's clearly indicated that the growth was measured in centimeters for this lab or for this data set. So you need to make sure that you scale them appropriately. You need to make sure you put an appropriate title on your graph. A lot of times it'll be the same one that you put on your data table. Make sure it's descriptive. And then go ahead and plot the points on the graph. So pause this, look back to what you did on your data table and create your line graph. And then when you're finished, resume and we'll finish the rest of these notes. Okay, so now quickly let's look at making a bar graph. Bar graphs are useful for showing comparisons of data that's collected by counting. Okay, so a bar graph has two axes, a horizontal axis and a vertical axis, just like the line graph did. Generally, the horizontal axis, the one that's on the bottom, is labeled, and the vertical axis is divided. So we've got divisions here, okay? The data are not related, so the bars are not going to touch each other. So this is different data than this is different data than this, and on, okay? We do still have a title. We have labels on the axes. We have appropriate scales, and because we're comparing two different things, we have a legend over here. The last thing that we're going to look at is making a circle graph. Circle graphs a lot of times are not often as used in science reporting, but you might see them a lot in journalistic newspapers or magazines or stuff like that. A circle graph is a great way to show relative size of the parts that form an entire body of data. So we're looking, most of the time this is looking at percentages because the circle represents the whole thing, and so you want to show how whatever it is that you're looking at is divided within that. So in the case in this video, or in this presentation, we're looking at US average indoor water use. So over 100% out of all the water that's used, 3% is used for dishwashers, 30% for bathing, we have 22% for washing machines, 28% is used for toilet use, etc. Okay, but you can see all of these add up to 100. So I want you guys to make up, using in your notes, you're going to make a pie chart, and then we'll talk about it when we get to class. So you are going to take this chart and you are going to denote the following information. In a particular high school, the number of students taking a science class follows. 50% are taking biology because that's the best class you could take, duh. 30% are taking chemistry, 10% are taking physics, and 10% are taking some other type of science class. So you are going to divide this up and show me how you would create a pie chart or a circle graph. Don't forget you need a title, and you need to represent the numbers, the percentages in there as well, okay? So this is the end of the video. If you have any questions, please make sure that you wrote them down somewhere in your notes, and we will discuss them the next time we have class. We'll also review, and I'll go over show you how the data table and the graphs that I asked you to set up should look, and we'll go from there. Have a great day.